Okay, so in the previous levels, level 1 and level 2, we talked about VXLAN, specifically MPBGP EVPN VXLAN, and how it allows us to build a leaf-spine topology and all the advantages of leaf-spine topology while still allowing one of the most critical functions that we have in the enterprise data center, which is vMotion. And then in the campus, it also provides endpoint mobility. So the same IP address and can exist in multiple buildings, etc., which might be good for network access control and some other things. So it's an important technology, but we haven't really talked about that technology specifically. So we're going to do that now. So just a quick review, MPBGP EVPN VXLAN, it's kind of a word salad, has us building a leaf spine topology, so we can have more than 2 spines. So this is how it differs from layer 2 leaf spine. So we can have this style of topology with all the benefits. All the links are forwarding, spanning tree isn't involved in that part. We still have spanning tree, but it's there just to make sure that we don't make a mistake in cabling. But day to day, spanning tree isn't involved in whether an interface is forwarding or not. So this will be some sort of layer 3 fabric here, and I've got a workload. So this is a virtual machine, and it's attached to one leaf or a pair of leaves typically, but I'm just going to show one here. And VXLAN is going to allow us to move around from one place to another. So quick review there. Let's talk about what it takes to build that type of network. So there's a couple things that we're going to need in order to build this, and we're going to go through them one by one. So this is going to be building an MPBGP EVPN VXLAN based network. Again, kind of a word salad, and we'll talk about what each of these components mean as well. So number one, we're going to need the topology. Now, VXLAN doesn't require a specific topology, but most of the time when we're implementing this, we're doing this so that we can enjoy the advantages of certain types of topologies, and that's going to be leaf spine, also known as a CLO network, or layer 3 fabric, or there's many names for it, but it's when we have spines, maybe super spines, leaves, subleaves, a hierarchical, we're not limited to 2. So that's the topology number 1 we need. Number 2, we need an underlay. So we need some sort of underlay network. And probably we can use just about any routing protocol that would work, but the 2, or rather technically 3 most popular routing protocols would be OSPF, EBGP, IBGP, and to a lesser extent, I have seen some ISIS. Just about anything will work, but those are the ones that primarily work. At Arista, we primarily recommend EBGP as an underlay, but it's not the only way that we can do it. There's other options, and it's more of an architectural choice versus a technical one, although we'll talk about some of that. Number 3, we're going to need the overlay. And this is only one protocol, that's MPBGP. So this part right here is replacing the flood and learn capabilities that we have with normal layer 2 switching, or the previous style of multicast, the older style, the previous style of VXLAN rather, which could either use multicast or it had in replication or ingress replication, depending on how you call it. But with EVPN, we're going to be using MPBGP EVPN. So that's the overlay. Next, we're going to need the tenants. Now, this is not a, the tenant part here is more like How do we do the layer 2 VNIs, the layer 3 VNIs, and what are even the differences between layer 2 VNIs and layer 3 VNIs? But basically, we're doing one L3 VNI per what we call a tenant, and then multiple L2 VNIs per tenant, probably more than one. And what even is a tenant? Tenant typically is going to be a VRF. And VRFs are locally significant to every leaf and spine, to every switch. And we need a way to communicate our VRF boundaries between different devices via the routing, so that we use route targets for that, and we'll talk about that in a little bit. So let's talk about the purposes of each of these. So the topology, that's just the physical connectivity. Connect. Just spelled that wrong. So we have our physical connectivity. The underlay network is to, basically, we need to put loopback 0 and 1 into the routing table. We need to make sure that we're using loopback 1 and loopback 0 on all of the leaves, and then typically just loopback 0 on the spines, and we need to make sure that those addresses are put into the routing table and they're accessible from every other leaf and spine. Next, we have the overlay, and this is going to be BGP peering. Between loopback zeros. And the tenants are going to be a combination of setting up our VRFs. We don't have to use VRFs, but it's best practice. We could put everything in the global routing table, but then we can't. Then segmentation's a little bit more difficult, and then the routing table gets a little bit more complicated. So even if we have just one quote-unquote tenant, we're still going to put it into a separate VRF. This is also going to be route targets, VLAN assignments, VLAN to VXLAN segments, etc. Setting all that up, and a few other things. So these are the things that we need in order to build out an MP, BGP, EVPN, VXLAN network. And now we're going to talk about them one by one.